Thank you all for taking your time to judge and voluntarily submit.
Sorry.
Hi, I'm Thomas. I'm a cadet engineer for Phoenix Force, and I'm going to tell you what Phoenix Force is all about. Our mission is to inspire young minds to create by solving problems in innovative and creative ways. Team Phoenix Force leads by example, paving the way for the next generation to build upon both our successes and our failures. We travel to schools, conventions, and conferences, present first, and encourage young adults to start programming, engineering, and inventing. By fostering both their growth and ours, we help to empower and a generation of curious, brilliant, and ambitious inventors, researchers, and leaders.
Alright, hi, I'm Moira. I'm a deputy team captain, and I'm also an engineer for Phoenix Force, and I'll be talking about part of the design for a robot. So, in this form, our robot, this is what we call origami mode. It is less than the 18 by 18 inch size and cube. However, when it expands, this is what we call our dragon mode. And this is extending up to 38 inches by 51 inches, which is 2.8 times bigger than the origami mode. And so we have these plexiglass side panels over here, that we etched with like a laser engraver. They're just good for production for the robot. And so the main design aspect of our robot that makes it really easy to collect minerals is we can collect them from the crater on the silver side without even having to turn around. So we move back a little bit towards the crater, pick them up with our collecting mechanism over here, dump it into the bucket, and then back into the lander once we move back. So that saves us a lot of time and a lot of moving around, and a lot of also risk involved with moving a robot around with three other robots in the arena. Yeah.
Hi, I'm Katie, and I'm the lead 3D printing designer and lead mechanics for Phoenix Force, and I'll tell you about our mechanic wheels that help us do the field. So what we have is we have article mechanic wheels, and they let us strafe side to side, forwards and backwards, so we can go in all directions, making it really easy to move around the field. So right now on our robot is one challenge that we faced is our weight issues. As you can see, our robot is pretty big. So we used to have a lot bigger wheels, but because of weight problem, we had to go to the smaller wheels that we have on our robot right now.
Hi, I'm Ashlyn. I'm the lead programmer and one of the team captains. And I'm going to be telling you about our camera that we have up here. So we take the camera cap off. And so we have this camera that we use with a TensorFlow algorithm to detect the minerals during our autonomous mode. And so we have it up on the lander latched, and so we found that that was the best position to start looking for the cubes with, because that gives us 155% increase in our the area that we could see. But then we also found that sometimes with the variability of where the minerals could be placed, that the camera only had about a 65% accuracy rate. So we mounted it on a servo, and we have a scanning program that we call CASMED, or the Camera Active Scanning Mineral Extended Detection. And so this increased our accuracy rate from about 65% to 95%. And so now it also helps communicate with us with our lights in our autonomous mode, and we have the lights on our robot turn white when the camera is scanning to help provide more light, and so that the colors from the lights don't interfere with the camera.
So I'll be talking more about the collecting mechanism that we have. So we had a lot of different prototypes involved over making our flipper mechanism. So it kind of started out with rubber bands on cardboard. We didn't find that worked too well. Then we moved to surgical tubing that we didn't also find that worked so well. So we ended up settling on these rubber flippers with the ridges on the side that help grab the both the minerals and the silver minerals. And so this is our trophy. It's a dragon egg, because the dragon's kind of our theme for our robot this year. So this is our trophy. It's been 3D printed by Katie. So it's got our team name on it and all of our team members' names on it on the back. And so the way that this sits on our collecting mechanism is via magnets. So we have 2 magnets embedded here and 2 embedded in the collector over here. So it just slides into place.
Hi, I'm Ariana. I'm a cadet engineer and cadet cab worker. I'll be talking about the collector and dumper mechanism. Thank you. So we originally have a vehicle collector which can collect both gold and silver minerals and then take it up to the dumper where it can then dump it into the lander. And so we originally prototyped all these pieces in cardboard so we know the correct shape and drill points for the screws. And then so we have this made out of polycarbonate because it's more flexible and easier to bend than plexiglass is. While our side panels are made of plexiglass because it can be laser cut. The polycarbonate lets off toxic fumes when it's laser cut.
Alright, so we talked a little bit about this before, but we have LED lights, which change based on what we're running. And so one of the biggest things is we have 3 different speeds that we use. So if it's in the blue speed, such as that, it runs at 50% power. So this is for more accurate lining up with the lander and during endgame so that we can raise ourselves up. We have the yellow speed, which is more for going back and forth between the crater where there's not a ton of room. So we want to make sure that we're not going to go crash into everything when we're moving around. And then we have the red speed, which is getting around the field as fast as possible. And the other thing we have is sometimes it's hard to see where the dumper is because of the electronics wall. So for me right now, I can only see about 50% of the dumper. So we have the lights change color based on if it's going in or out, so that it's easy for me to know if I'm going the correct direction, just in case I forget. And so when we start our autonomous programs, the colors will flash according to which side we are on. So if we are on the red team and we are on the gold side of the lander, it will flash red and gold so that we have a visual cue to know that we selected the correct autonomous mode, so that it will run the best that it can. Yeah, and then it turns to white at the very end to help the camera and or not disrupt it with all the colors. And so if you actually look at the front of the robot right now, part of that is flashing, and so that is because we soldered all of the LEDs and stuff together, so we just have a loose connection that we're gonna have to fix up a little bit later, but but yeah, so we soldered everything together so that it was all custom and everything, but sometimes there's little issues here and there, but we'll fix it up, so.
So, these things right here are clamps. So, the clamp, okay, yep. So the clamps keep this thing, not this, okay, the slider from lifting up when it's like on the lander. So like when it's on the lander and it's not actually engaged, so like it's not holding itself, it won't just fall down and won't get the landing points for that. So this here is the latch. It latches onto the lander, as what it's called. And then as it pulls up, pull it up, and then so that's how it latches. So in autonomous, when it lowers itself down, but the way how the latch opens without having to put the time in and all that stuff, which is not as accurate as this thing right here. So there's a touch sensor back here which automatically stops it when it hits it, so it doesn't go too far or not enough, So it won't be caught on land, or it automatically just stops. So yeah, it helps, like when we can't see the, it helps when we can't actually see this stuff to just know when it's open and closed and stuff, so yeah.
So yeah, Tom's just kind of explained how it lands. So we have the clamps will open up, the lifter will raise, and then the latch will open. And then from there it will have already, or before all that, the camera will run so it knows left, right, or center. And then it will go based on which path. Based on which path it does, and it will display a different color. So if it sees the gold mineral on the left side, it will display lime. If it sees it in the center, it displays cyan. And if it sees it on the right, it displays red. So that's another visual cue for us to know before it starts running which way it's going, just so we are prepared. And then it will go to the depot, deliver our trophy, and then it will drive over to the freighter.
Hi, I'm Kara. I am the CAD designer, and I'm going to tell you about the process of CAD designing. So at the beginning of the year in fall, we actually got sponsored by SolidWorks, and they gave us their program for free. None of us or our coaches had ever used SolidWorks before, so it was our goal this year to figure out how to use it. We got a lot of parts we needed for building our robot from the websites, but we actually had to build some of the parts, like the wheel hub, from scratch using SolidWorks. So it was really good to figure out how to use it, how to put stuff together, how to build sub-assemblies, how to use stuff from sketches. And now we have our full robot.
So this is our CAD robot. You can get it off our website, and then once you're in there, you can then look at it, and you can expand it, and so someone could actually go in and build our robot exactly the same as it is now to the screw.
So another thing that we had about working with SolidWorks for designing our robot this year is when we were trying to upload these designs to our website, we were having a lot of issues with having it show up and having people view it. So we actually got in contact with some of the top developers at SolidWorks, and they helped us, and we helped them figure out what was going on, what was wrong, helped them figure out problems in their programming, and helped us put our designs online for people to see and understand. So it was a very mutually beneficial working relationship.
So we have quite a few 3D printed parts on our robot that we designed ourselves. So as a team, how we go about designing our 3D printed parts is as a team we'll figure out what things we need on our robot that we can't use that is like pre-made, like metal stuff. So so the design of our process of designing is as a team we'll get together and everybody will separately we'll draw out some ideas to help solve our problems, and then we'll come together and figure out what best works with what the issue or problem that we have is, and then what we do is I will design it on either 123D or SolidWorks, and then we print it and test it and repeat if necessary for most of our 3D printed parts. Some 3D printed parts that we have is we have our power button switch. So we have a spot that protects the power button and a good spot to hold it. We've got a phone holder, and then where does the cap go for the? Oh, I have it in my pocket. And then one thing is we 3D designed our cap to our lens because at the first tournament we lost the lens cap, so we 3D printed it yellow, so we will never lose it again.
Yes.
And it's being such a bright color also makes it easier for us to remember to take it off.
Yeah.
Alright, so hi, I'm Veronica. I am the team manager and the outreach coordinator, and I'm going to tell you about our outreach. So a few facts that we have are we did 9 different events this year. We've had over 1,200 kids involved with what our outreach does. We've had over 150 hours of work, and we've traveled over 550 miles for all of our outreach. So we do a lot of volunteering for FLL events. So we volunteered at the FLL state tournament for hydrodynamics. We had some referees and some table resetters. And then this year we volunteered at the FLL Oak Creek and the McWanago tournaments. And we also did some refereeing and some timing and then some table resetting. And then so we also do local events in our area. So we've done the Madison Mini Maker Fair, which is like an engineering fair, and we had a lot of different people from a very wide range of ages trying out our robot and like demoing it, driving it, and also learning about FIRST for the first time, no pun intended. And we have a science night at the middle school that we show off our robot at every year, and that's how we recruit new members. Like we recruited Moira here from that a few years ago, and we pretty much have 5th through 8th graders trying out our robots and getting introduced to kind of robots and FIRST as well. And then we have a 4-H robotics night that we did this year, where we had K through 12 kids trying out our robot and being introduced to robotics for the first time and getting to experience kind of how they work and how to drive them. And we also have like a few miscellaneous things that we do, like we mentored an FLL team that last year, and they're here now. These three came from it. And Hannah does Code CS for girls.
Yep, so Code CS is a program in my school where we take 4th through 8th grade girls that are interested in learning about coding, and we focus on a different area of coding, or such as like a different language. And this year we actually decided to focus on robotics. So because of my experience in FLO, I decided to use Mindstorms and FLL to try and get them inspired in that way.
And then Ashlyn does a conference called That Conference.
Yeah, so that conference is a programmer and developer conference that happens every year up in the Dells. And there I give presentations to everyone from professionals to grade school level children about our robot. I do one about FIRST every year, and then me, my little sister, and my mom do one about everything from 3D designing to using the 3D paint stuff. And so we usually give 1 to 2 every year.
And we also share our 3D designs on Thingiverse. We've had about 40 views overall, and we've had numerous downloads. We've actually gotten some requests for specifically our zip tie holders that will fit into the X-rails that are really awesome for putting back the wires. We've had a team request that to be uploaded. And we also share our SolidWorks designs online so that people can see our robot and see different parts of it. And we also help teams at some of the tournaments. Like last tournament we had, there was a team that didn't have a phone holder, and their phone was kind of just rubber banded onto their robot. So we gave them one of our old phone holders that was like a prototype of what we have now. And then today actually, Ashlyn helped the team with programming. Do you want to explain a little more?
Yeah, it was just a Gemini, the team Gemini. They had a few errors in the programming, like some.
Yeah. So they were working on their autonomous, and so since we know a decent amount about autonomous, we went over and just helped them so that they could get that done.
So we also do quite a bit of like global outreach. So we have a calculator. I'll show you this here. So we use this. It's on the back of your pamphlets. So we have this. So how we use it is teams can enter team names here, and then score different, like how they did. So you can like add cubes and spheres, and then see how they did like claiming and stuff like that. And then it'll show the points up at the top. I don't know why that's not showing the points. And then at the end, you can export it as a Excel file or a PDF file, which is really helpful for scouting. And we've shared this with, we've shared it directly with 180 teams around the states and around the globe. And we'll have this at our table if you guys are interested in coming out and actually trying it. So we shared it on Instagram, where we do a lot of our like global kind of outreach. So we have a lot of teams that we communicate with through there. Like we have a partner team in New Jersey that we get help on like small aspects of our robot. We help them with small aspects of theirs, and we got feedback of one of our judges' rooms performances from them. And we also helped a team in Romania with their 3D printing applications, because they didn't really know what application to use.
So I'm going to have to interrupt. We are at time. So, sorry, we have to be fair to everyone. Thank you so much for coming and talking with us, and good luck today.
Thank you.
Awesome.
Don't forget.
Yeah.